So what we're going to start doing now is taking the initial simplex tableaus that we had, and we're going to pick a pivot in such a way that it heads us towards the optimal solution. Here we have an initial simplex tableau. The first row has 2, 3, 1, 0, 0, 0, 11. The second row has 5, 2, 0, 1, 0, 0, 20. The third row has 1, 1, 0, 0, 1, 0, 4. And the last row is -10, -12, 0, 0, 0, 1, 0. This is one of the matrices that we've dealt with. And like I explained before, in this form right now, we've got x1 and x2 as being our non-basic variables. So if I looked at the solution for this, it would be x1 and x2 being 0, s1 being 11, s2 being 20, s3 being 4, and the z value for that would be 0. And I can see that from the last row because remember, if x1 and x2 are equal to 0, the only thing left is z equals 0. And that's definitely not going to be our optimal solution. So to find another feasible solution, we're going to find the column with the most negative indicator. In this case, I see a -12 there. That's the most negative number in the indicator row. If you ever run into the situation where two indicators are most negative, then we'll just go ahead and pick the one that's on the left. This column right here that I've picked out by looking at that -12 is called my pivot column. We need to put our pivot in that column. To find out which row we're going to do it, we need to form a quotient with the numerator coming from the last column and the denominator coming from the pivot column. 11 over 3 would be 11/3, which is 3 2/3. 20 over 2, which would be 10. 4 over 1, which would be 4. Now we're going to pick the ratio that's the very smallest, so that's going to be the 3 2/3. So that tells us where we're going to put our pivot. So we need our pivot to become a 1, so I'm going to take that entire first row and multiply it by 1/3. So I'm going to take 1/3 times row 1 and put the result in row 1. When I do that, the first row becomes 2/3, 1, 1/3, 0, 0, 0, 11/3. Now that I've put my pivot in there being a 1, now we have to put zeros below that. So I'm going to have to multiply that first row by -2 and add it to the second row to get rid of the 0 or the 2 in the second row. I'll have to multiply it by -1 and add it to row 3 to put a 0 there. And I'll have to multiply it by 12 and add it to the last row to get rid of that -12. So I've gone ahead and I've listed those steps out here. And if we did that on a graphing calculator after entering in the matrix into the matrix editor and then doing our row ops, what you would find is that your second row becomes 11/3, 0 like we wanted it, -2/3, 1, 0, 0, 38/3. The third row would become 1/3, 0, -1/3, 0, 1, 0, and 1/3. The last row would become -2, 0, 4, 0, 0, 1, and 44. So looking at this matrix that we just found, we see that the non-basic variables are x1 and s1, and the basic variables are x2, s2, and s3. So this corresponds to a solution of x1 being 0, s1 being 0, x2 is 11/3, s2 is 38/3, and s3 is 1/3. The problem is this is not the optimal solution. It leads to z equals 44, but we know we're not at an optimal solution because in my indicator row here, I still have a negative number. We're going to continue this process of putting in a pivot, getting ones and zeros until we no longer get a negative number in our indicator row. So now we have to find the pivot again. I take the most negative number, there's only one there now. I go ahead and form the ratio between the last column and the pivot column. So I have 11/3 divided by 2/3, which is 5.5. 38/3 divided by 11/3, which is 3 5/11. 1/3 divided by 1/3, which comes out to be 1. So 1 is the smallest quotient that I've just formed there, the smallest ratio. So that tells me that my pivot is going to be where that 1/3 is. So now I'm going to take that pivot, and to make that into a 1, I'm going to multiply row 3 times 3 and put the result in row 3. And when I do that, I get 1, 0, -1, 0, 3, 0, and 1. All of these steps that I'm showing, you can check for yourself. So once I get that 1, now I need to put zeros above and zeros below. So I'm going to have to multiply by -2/3 to get rid of row 1 and put a 0 there. I'm going to have to multiply by -11/3 to put a 0 above that 1. And I'm going to have to multiply by 2 to end up getting a 0 below the 1. So here I've gone ahead and I've listed out those steps. -2/3 times row 3 plus row 1, put the result in row 1. That puts the 0 at the top of the column. -11/3 times row 3 plus row 2, put the result in row 2. That puts the 0 in the second row of the pivot column. And 2 times row 3 plus row 4, put the result in row 4. That puts the 0 down in the very bottom row. If I do all those row operations to the rest of this matrix, get the matrix that you see here, and notice that now my indicators are all positive. That tells me that I've found the optimal solution. Now I know the non-basic variables are S1 and S3. So those are the things that are going to be set equal to 0. And so if we cover up those columns, we can actually see what our solution is going to be. So for x2, I get 3. For x1, I get 1. I get s2 to be 9, but remember that's just a slack variable. That's not going to be a part of my final solution.